got two people out there in Zoom land. All right, so there's my daughter for Halloween. She's a ladybug. Everybody loved her shoes, her purse, the candy purse. Let's see, there are two people in Zoom, 3, 4, 5, 6, 7, 8, 9. There's 9 people here. 10. All right, so we got 10 people here out of 25. And I just graded like Tuesday's exam. Only 6 people turned in the quiz and the exam out of 25. I mean, I do the quizzes for you every day. And right after class, if you hung around, you'd see I do the exams for you as well every day. That's 60% of your grade, just from being here. So, I mean, come on, what do I got to do? All right, so here is last time's exam. The ASG annuity in life. I'm old. Me too. ASG annuity in life offered an annuity that pays, so let's see, R is 0.0725. So we're looking at an ordinary annuity, compounded monthly, so that means M is 12. $1,000 is deposited every month, so our payment is $1,000. Okay. How much is the account after 15 years? All right, so since this is the payments come in monthly and it's compounded monthly, that means it's a regular annuity or ordinary annuity. So the future value was the payment, and see if I could remember, what was it, 1 plus I to the n minus 1 over I, actually remember, where n is the total number of payments made. So it's n payments per year times the number of years. So 12 times 15, and I didn't memorize my multiplication table that far up, 180. And then I is the rate per period, right? Since this is the annual rate and this is the number of periods in a year, this is your rate per period. So 0.0725 over 12. Now we just plug in our numbers. The payment is $1,000. 1 plus I is 0.0725 over 12 minus 1. Oh, and to the nth power, so this needs to be to the 180th power, and divided by I, which is that. So y'all need to, some of y'all are writing down everything correctly, but you're plugging it into your calculator wrong and you're getting the wrong answers. Okay? Half the problem is just writing down the R, the M, the P, and C, just knowing the definitions and then knowing the formula. The other half is just typing it into your calculator correctly. You know who you are. You've done it twice in a row. All right. So during class, when we're doing this, you need to practice typing this stuff in at the same time that I'm typing it in, so you can check and make sure you're getting the same numbers, so you know you're doing it right. Otherwise, it's just kind of a guessing game. All right. So I did this last time, and let's see what I got. For those of you who hang around after class, you'd know what I got. I did it right after class. This is what I got. Let's see. Boom. $323,943.07. So when you get a number, the first thing you want to do is look at it and ask, does that seem reasonable? Let's see, I paid $1,000 a month for 15 years. Well, that's $12,000 over 15 years. So that would be what, 180 total payments of $1,000. So my principal, the amount that I put in has been $180,000, right? Plus I'm collecting interest. So this number at least needs to be bigger than $180,000, right? So if you get like 13,000 there, you know you did something wrong. The future value of $180,000 investment should be more than 180,000. Okay. If you get like 323 million, that's probably too much, right? So just use your common sense to and apply it to give you a little bit of confidence in the answer, right? But I mean, if you're dealing with somebody's money, of course you should double check your work and probably have somebody else do it and then compare both your results. So it's two different brains. That's typically how you do important things. It's how you do science, right? Somebody else has to do the same experiment independently of you and replicate the result. And that's how we build confidence. So that's how much it's worth, but we also need to answer how much of it is interest. Well, the interest is going to be, right, this future value minus all the money that we put in, right? And the money that we put in is the payments times the number of payments we've made. Does that make sense? $1,000 a month times 180 months is how much we paid in. Subtract off the future value, and the rest must be interest. So we have, there's our future value minus 1,000 times 180. And when I plug that in before, this is what I got, 143,000, which we might have been able to do in our head to subtract 180,000 from 323. So that's what you should have gotten. And now let's look at number 2. All right, we have an annuity. It pays 0.055 compounded monthly. So M is 12. What equal monthly deposit should be made into this annuity? So what is the PMT? What is the payment in order to have a future value of $100,000 in 10 years? All right, well, we use this same formula, okay? But see, this it's an ordinary annuity because it's compounded monthly and we're making monthly payments. Remember, for it to be an ordinary annuity, for this formula to work, you have to make the payments at the same time that the interest is being collected. Those have to be at the same time, okay? But we want to know what the payment is. So all we need to do is solve for the payment. So basically, we just divide both sides by this, right? Which we can write that in a smarter way. We could say PMT is the future value. Instead of dividing by this guy, since it's a fraction, we'll multiply by its reciprocal. All right, so notice I switched them. Boop, boop. So that's how, you know, we're dividing by a fraction. It's the same thing as multiplying by its reciprocal, right? So now we just need to plug in future value. Let's see, is $100,000. And we need an I and an N. Well, I, the rate per period, should be 0.055 over 12. So let's plug that in. 0.055 over 12 over 1 plus 0.055 over 12 to the n power. Well, n is m times t. M is 12 months a year times 10 years is 120 total periods. So we have the 120th power, and then we need to subtract 1. Okay. And if you're when we have the quiz, if you're having issues with the calculator, whichever calculator you're using, or if the calculator you have just sucks, and maybe there might be a better one you could use, right? The whole point of the quiz is collaboration to get y'all to communicate with one another and help one another out. So share whatever approach you're using, whether it's a regular calculator or your phone or Desmos online or whatever. Explore all the other options, right? Compare, because y'all still have to take calculus, right? So find out which one you like the best, right? Okay, so if we put this into our calculators, we should get, well, that doesn't look right. I have a comma in there for no reason. We should get $626.93. Okay. That's how much the monthly payment should be, so that in 10 years you have $100,000. That's not bad. I mean, this is about a car payment and a half for me. My battery's dead. I just left the key in. It wasn't like turned on or anything. I didn't have the lights on. The key was just like turned. The AC wasn't running. It took 3 hours and my battery was dead. I tried and it wouldn't work. So either my jumper is crap or I have like 3 different battery charger jumper things, you know, that or the extension cable. I have one of those portable jumpers, but it was dead. Yeah. Yeah, it sucked. Okay, so there's your exam. Oh, I have to mention, in Canvas, um, these folders, like where I put the lecture notes, like if I go to the lecture notes here, and I go down, it only goes to 20. Yesterday I put in, or Tuesday, we had lecture 21 and I uploaded the file. But for some reason, after 20 files, the folder will no longer display the files. It'll pretend to, like it'll show that I uploaded it and it'll be there for like an hour and then all of a sudden it won't show up anymore. So any of them after 20 files, I had to make these new folders called more lecture notes and more daily quizzes. So anything after 20, I'm putting them in there. Now I think you could still find them, like apparently like if you search for it, it'll show up, you know, but for some students it will, and for some students it won't, right? So it's real quirky, but yeah, it's Canvas. It caught me off guard last semester, you know, I was like, what the hell, you know? People are like, you didn't upload it, and I'm like, yes, I did, and I looked and it's not there, and I was like, man, I know I quit doing drugs years ago, you know? So, yeah, that's where they're gonna be in the more folders, all right? So let's pick some problems for a quiz, right? This is daily quiz number 22. All right, let's pick a problem or two. Let's see. Look at 52 here. So here's an ordinary annuity problem, but we have to solve for the time. Oh wait, this one might suck. Which one was it? Right, there was one, remember we couldn't solve for I. Basically, you had to graph it to figure out, because you can't get the I's together, right? So I don't want to do that. That's lame, right? You should be able to solve for N though. Which is this one? They want to solve for T, right? When would, and so this one's a solve for T. Let's see if solving for T. Where does T isn't even in this equation, is it? Sure it is. N is MT, isn't it? So just replace N with MT. And since T only shows up once, it shouldn't be a problem for y'all to be able to solve for T. You get it out of the exponent by taking the natural log, okay? So y'all can do this without graphing or whatever. Lame. Let's pick another one here. When would, yeah, let's do number this one too. We'll do both of these where you solve for T. Don't just sit there and wait for me to do it, right? You need to work on this your own. Math is not a spectator sport, right? You can watch people swim all day long. You're not gonna be able to swim if you just jump in the water, right? You have to actually do it yourself, right? That's what gets the neurons all wired up for you. So let's take I don't know, what, 10 minutes on these? I should be able to do these in 10 minutes. All right. So at 5:56, we will work these together. Okay, so when would an ordinary annuity, so we're asking for the time, an ordinary annuity consisting of monthly payments, so our PMT is 200 bucks at 5%, so our $200, R is 0.05, compounded monthly, so M is 12, be worth, when would it be worth more than a principal of 10,000? All right, invested at, this one's complicated. All right, let's figure this out. When would an ordinary annuity consisting of this many payments at this percent compounded monthly, when would this be worth more than a principal of 10,000 invested at 7.5%? So we have two different investments here. We have a regular one that's just compounded monthly, and we have an annuity compounded monthly. So we're trying to figure out what's better, to plug in money all at once or make the payments, right? So for the first one here, we would have our future value, all right, is PMT 1 plus I to the n minus 1 over I, right? So for the first one, our PMT is 200. And what is our I here? Our I is rate per period. So 0.05 over 12. So this is 0.05 over 12. Our N is MT, right? Well, our M is 12, and then we have a T here. So we don't know what T is, right? T is the variable. So we have 12T, all right? And then we have our minus 1 over 0.05 divided by 12. Okay, so that's the future value for the first loan, right? Well, now we're comparing that to the other one. When is this annuity's future value worth more than if we invested 10,000 at 7.5% compounded monthly? So I'll call this FV1, and we want to know when this becomes more than this one. So FV2 here would be P times 1 plus R over M to the MT. All right, that's for compound, regular compound interest. So they're saying a principal of 10,000, and we have 1 plus R over M is 0.05 divided by 12 to the 12T. So we want to know, when is this bigger than this? We're solving an inequality here. To solve an inequality, first you find out when they're equal, right? And then after that, this one is going to end up paying more because you're continuously plugging money into this one, right? So eventually this one will overcome that one. So at first, this one's going to be less, then they're going to be equal, and then it's going to become more. So let's find out when they're equal, right? Because after that, our first one will take over. So if we set these equal to one another, let me make some more room here. Set these equal to one another. Set this. This is what we want to find out, equal to this. So we want to solve for T here. I hope this isn't one of those stupid graphing ones. All right, so first thing, we can divide both sides by the dollar sign, right? The number we're going to get is going to be a time, units of time. And now we can simplify. Let's see. Uh, what is this? We could take, oh yeah, let's get rid of some of these numbers just to make it easier to look at, right? If I take 200, divide by 0.05, and multiply by 12, all right, this is just 4,800. And then I have times, let's simplify this guy in here too. So I have, there's clear button, clear. 0.05 divided by 12, add 1. So this is 1.0417. I'm going to keep the number. I'm going to keep 4 digits here. What? Yeah. For the FET, the R, oh yeah, I have the wrong R here. It's 0.075. There we go. And that's the right principal, right? It's compounded monthly. All right, that looks good. All right. So I'm just taking this and I'm going to approximate it to 4 decimal places. I don't like that square bracket. -1. And then over here, I have 10,000. I'm just going to take that and simplify it to a decimal. So I have 0.075 divided by 12, add 1. This is 1.00625 to the 12t. And actually, I can get rid of this parenthesis here now. I'll do this just to make it a multiplying. So let's consolidate this crap here. If I move this under here, I might be able to do something. Now this number is bigger. So if I divide both sides by 10,000, I'm going to get 48 times this is equal to this guy. Right? So let's see. This is FV1 equals FV2 if and only if and only if and only if. Continue to simplify. If I multiply this thing out, I have 48 times 1.0417 to the 12t minus 48 equals this. Now, why am I doing this? I got to get these t's out of the exponents. And that means I'm going to be taking a log of both sides. Remember the log trick? The log of whatever, x to the r is r log of x. You can always take that and pull it out. And we also have the other tricks. The log of m times n is the log of m plus the log of n. Remember that? We had a whole section on that. So here we have something times something, right? So if I take, say, natural log of both sides, natural log of, I don't know, that doesn't look good. Well, we can still do it. Let's see what we can do here. Let's see, this is a log of a difference. We'd have to do some creative math here. So this is a difference, right? So we could turn this into natural log of this divided by 48, right? And over here, I could pull the t out. This is 12t times the natural log of 1.00625. We might just do one of these because this is more hassle than I hoped it would be. All right, so far we've used things that you know how to do, right? This, we want to take this and pull it out, but we can't do that because it's only this number to that power. We'd have to have all of this to that power, right? Right, it's log of what, m to the r. is r times log of m. The whole thing inside has to be to that exponent for you to be able to pull the exponent out, right? And since it's only this, well, we can what? Cancel out our 48s, right? Boom, that's convenient. So that means we can take this and pull it out. So we get 12, why do I have two n's here? 12t natural log 1.0417 equals 12t natural log 1.00625. This doesn't look good because we could just divide out our t's here. Well, if I move this over and then I factor out my t would have to be, well, I'd have t times 12, 12 natural log 1.0417 minus 12 natural log of 1.00625. And the only time that happens is when t is 0. Anybody got any better ideas? I think we pulled, I mean, we did everything right. We set our two values, our future values equal to one another. We need to solve for t. This must be one of those graphing ones. Damn it. Yeah, graph them both and see where they intersect is what you have to do. But I mean, we use the legit tricks, right? We divide both sides. We have this minus 1 is what's screwing us here. This is stuff you do in business. None of this is going to be useful in your calculus class. I swear, like 3/4 of the stuff you learn in here, you'll never see it in your next math class. I'm still trying to wrap my mind around it. We could do something tricky, like, yeah. Well, let's see. What if we? I'm gonna try something here. What if I took this, the number 1 here, and I wrote it like, I don't know if that would help. Let's say it's 1 to the 12t power. 1 to any power is still 1, right? Well, maybe I should check and make sure I didn't make a mistake before I try wild ass guessing here. So we took natural log of both sides, and the natural log of a difference would be division. So we have that divided by that. Those cancel out. So that works. And then we can pull that out, and we pulled that one out. But we get this 12t on both sides that just cancels out of the equation. I don't see why. Hold on, let's see. Set them equal to one another. Let's see. Let's look at this stupid section here. I figured for sure we could solve for t. I should have read the rest of the problem, huh? I was like, sure, we could solve for time. Like, when is it going to be worth this amount? We could do that. But comparing two of them is not something you can do, like with algebra.
I have a friend who like went through calculus and pencil and all that.
Yeah.
And sometimes I ask him for help with these, like something pencil.
Yeah.
And he was like, I don't understand how you can do this without pencil.
Yeah.
Like some of these things just like
a lot of the stuff
so
in this next section, we're going to do a whole lot of the stuff that's like, it's like pages and pages of algebra. But when you get to the calculus class, it's just one line of math.
yeah, exactly. It's like
Why do they bother? That's the other question I had. Not a lot of this stuff. All right. Well, I mean, it gets you like, you get a lot of the business jargon down. And I guess when you get to calculus, you can appreciate it, right? That's the whole point.
Yeah, but if you tell them, like, show me examples.
Yeah, I guess this one is like one of those where you have to graph them, right? So, and see where they intersect. So basically you set these up, set these equal to one another. Instead of doing that, you'd graph this and you'd graph this as a function of time, and then you look and see where they cross. That's it. I mean, that's faster than doing the math, right? So, so we'll put it right here. Instead, graph FV1 and FV2 and look at where they intersect. Apparently, we don't have the math in here that y'all have learned anyways that allows you to actually solve analytically for T, okay? It ticks me off because I think, I mean, I restricted myself to only stuff that we could use, but we're losing information somehow.
I think we know why the test one is.
Well, they're not, that's not this course. This course is gonna stick around for a long time. And it's my other class that they're canceling. Yeah, I forgot which class I was in. Happens when you have 6 different subjects, all right? Yeah, I wasn't expecting to have 2 different T's here. I was expecting to have something like this, where we know this and we're trying to solve for T. All right, that we could do. I mean, all we've done in here is just the logs, like in this example, I mean, from here to here, right? We just set the future values equal to one another. We're solving for time. The time shows up twice. We divided both sides by 10,000. That's, you can do that, all right? That's math from in here. We multiplied this guy out. We can take a natural log of both sides. That's taught in this class. And we know that log of m minus log of n is log of m divided by n. So that's what we did from here to here. We just have this and then divide by that. On this side, we just pulled the exponent out. That's legit. We can do that. These canceled. That's okay. And then once we just have natural log of a thing to an exponent, you can pull the exponent out. And then I move this thing to the other side of the equation. At that point, the only way that this is going to be true is when if T is 0, the only solution. I think these things where we're, some of these steps, remember the natural logs, like we had to be careful because it introduced solutions, but this is something where we're losing solutions. Unless I'm reading the problem wrong. I mean, it's possible they're never equal to one another, right? Except for at time 0 when they're both $0, right? So maybe everything we did was just right. It has to be the interpretation of the problem here. Because if you start off, you pay 200 bucks, right? So this one's definitely less than this one. And you plug in 10,000 bucks and then you let it roll. So it starts off at 10,000 and it's slowly collecting interest. Did I write something down wrong? 1 plus R over M to the, no, MT. Huh? It does have a higher interest rate, right? I mean, it's possible that, but that would be, I mean, it is possible if there's enough money in here, I mean, collecting interest. I guess the best way would be to graph these, right? So you could see like, how does this, you know, so this one would graph look like that, and then this one would start off at higher, right? And then they cross somewhere. But it's possible they wouldn't cross, right? Because this is a higher interest rate and you're starting off with more. So
if the limit cross, how does one, does that mean it can never be more?
yeah, if we graph them, we'll find out real quick. Let's graph these. so we know.
Does that mean they can't, it's just not possible?
It means never, it
Yeah.
means never, yeah.
Never before.
So let's do that. What was the first function? 200 times, oops, I'm gonna need two parentheses, right? Is 1 plus, what was it, 0.05 divided by 12 to the, what power? Oh yeah, okay. To the 12x okay, minus 1, and then all of that is divided by 0.05 divided by 12. Does that look right with all the parentheses in there? Yeah, I got an equal sign in there. What's that supposed to be, a plus? Yeah, 1 plus 0.05 over 12 to the 12x, all that minus 1. All right, so there's one of them. I guess we're gonna have to do a handy zoom here. What the hell, man? There. These are tiny numbers though. So this is t. Here our x is our t value, time passing. So this doesn't look good at all. It's all right. Let's zoom out. And I need to look at this. There. Now we'll zoom out. Zoom out, zoom out. Jesus Christ. All right. So that's the amount up there, right? So yeah, the vertical line is the future value, right? So there we go. Now we're getting some curves. So there, we could see it increases over time. That was challenging. Now let's try the other one. What is the other one here? 10,000 and 5%. Okay. Now let's try another one here. Function, insert function. We had 10,000 times 1 plus 0.075 divided by 12 to the 12x. In this case, 3x. We'll change this to blue. All right, so there is a point right there. Let's see if we can zoom in right here. Right there at 5.5 years. All right, so let's paste that in there. Let's get rid of this. I'll put that one and zoom out. So yeah, graphing is awesome, right? You can just look at a picture. So the answer is approximately, t is approximately 5.5 years. All right. So this doesn't work. This is what you want to do. And one problem is enough of this crap. So, man. So this is the same thing. We could set it up. Why not? If we're doing it. So we have an ordinary annuity consisting of quarterly payments. So quarterly payments means M is 4, PMT is 500, 6%, and then we're comparing that. So future value one is 500 times one plus I, right? I is R over M, which is 0.06 divided by 4. So 0.06 divided by 4 to the 4t, because that's what n is, minus 1 over 0.06 divided by 4. So this is, I'll call it FV1 of t. So it's a function of time. This one's a function of time. So this one here, the second one is P is 5,000 and R is 4%. Simple interest here. Oh, that's a good question. All right. So what is simple interest? The amount is principal times 1 plus RT. All right. So we have 5,000 times 1 plus R is 0.06 and then times T. So graph these and see where they intersect. Graph and look at intersection. Intersection. There you go. No, it didn't work. I would say. Graph and look at intersection. I guess I can get rid of this. And that didn't work. And get rid of this whole page. Boop. Here's the zoom in. Oh no, we don't even need that. T is approximately 5.5 years. And then number 2. And I don't want to bother graphing because it's a waste of time. All right. There's the whole class. Again, where were we? We were in 3.4. So well, we know annuities inside and out now, don't we? What you can solve for, what you can't.
And easier way.
Yeah, the whole graphing method. 3.4. So we started this last time. Let's just find our formula. So it's all the same stuff. Here we go. Here's our formula we found last time. Do the same methods that we found the annuity formula. Okay, so we're in 3.4. What are these? Present value, periodic payment, rate per, okay, so this is where this is still another ordinary annuity. Okay, yeah, this is where you, what is it, you invest a bunch of money and then every month you take a little bit out basically until it's gone. Yeah, remember it looks like the last one, but it's to the negative end because we're taking payments out. That's why it's also subtracting, right? So you're still collecting interest on what's in there, been invested. It's just each month you're taking some money out, and it's the same amount of money, and it's at the same time that you collect interest. Okay. So let's plug and chug here. I don't want to spend 1,000 years on this one. I don't know what kind of problems they have for this last section in your MyMathLab homework. I don't know if they want you to do the kinds where you have to graph and stuff to find the answer. I imagine they have a problem or two, 'cause that was one of the standard examples. There's only 4 examples, and that was one of them, so I guess we kind of need to cover it if you're going to be able to do the homework. What is the present value of an annuity that pays $200 a month? So PMT is 200 for 5 years. If money is worth 6% compounded monthly. All right, so let's look at our formula. Here's our formula. I is the same thing as it was before. It's R over M. N is going to be M times T. So M times T is 60. Plug the numbers in and you get 10,000. All right. 10,300 bucks. So let's straight up plug and chug. Match problem 1 is going to be exactly the same thing. Just plug it into the new formula. Let's look at example 2 here. And I don't want that in the way. Let's scroll down. Lincoln Benefit Life offered an ordinary annuity that earned this much compounded annually. That means M is 1. A person plans to make equal annual deposits into this account for 25 years. So here we're depositing into the account for 25 years. So that's the future value that we used from the last section, the one that we've been using over and over again, right? Because this is making deposits. Then after that, we're going to start making withdrawals, 20 withdrawals. So that means for 20 years. So I'll call this T1 and then T2, 20. So since it's annual, it's once a year. So for 20 years, it's 20. I'll call this M2. All right. So the number of periods in the second thing that's going on, right? So 25 years of making payments. After that, 20 years of taking money out. So I'll call this PMT2, 25,000, 25,000. Well, M is the same for M1 or M2. Reducing the balance to 0. How much must be deposited annually to accumulate sufficient funds? How much must, so that's the first 25 years. So we're asking for PMT1. So for the first thing that happens, the first 25 years, to provide for these payments. And then how much total interest is earned. So first off, we need the first, where is our little formula here? This is our annuity for the first 25 years, right? So first 25 years. All right, we're making, I'll call this payment 1. We're making payments for some amount. We don't know. Okay. Where's our numbers? Let's see. There we go. There's our rate, 25 years. Ordinary new, this percent annually, 25 years. So we have whatever this payment amount is. The interest rate was 0.065. So I is 0.065 divided by M. So because it's once per year, so it's just 0.065. So we could just really write this as 1.065. Then the nth power, N is M times T. N is 1. T is 25 years. So we're making these payments for 25 years. We have that minus 1 over I, and I was 0.065. All right? So we're gonna have some kind of future value making payments. I don't know what the future value is. It depends on the payments, right? Okay, so after that, we have 20 years uh, withdrawing 25,000 a year. So that's when this guy comes up, okay? So the next, what was it, 20 years? 20 years. What is it? Present value. This is the present value of all payments. So this present value is going to be that one's future value, right? So after 25 years, you have that much. So 25 years from now, that future value is going to be our present value. Okay, so I'm just going to call it present value. So these are going to be equal, right? The present value in 25 years is the future value now. So we'd have this PMT though is different than this one, okay? This PMT is the 25,000 that we're taking out every year. That's the payment out. So we'd have 25,000, 1 minus 1 plus I. So this second part, it's the same interest rate because it's the same account. So it's still 0.065. So we can just write this as 1.065. And where's our formula? To the minus n. Well, this is 20 years instead of 25. And then we have over I. All right, so that's what happens the second 25 years. And these have to be equal. So we're setting, since the present values are the same here, we set these equal to one another. And you solve for this, right? This is just a big number. So basically calculate that and then divide this by it. Let's look at their little solution here. That's what they're going to do. So here's your first 25 years. And at the end, you have a future value. So the formula from last section equals the formula from this section. This one has a t equals 25. The other one has t equals 20. You just plug them into your equations and set them equal to one another. After that, the math is simple. Here's the first part. We're given the required withdrawals. We begin by finding the present value. So here was present value, which we can actually find out. It was just one big number, right? So up here, the present value, this is all numbers. There's no letters there, right? It's this side that had the only thing that we needed to solve for. So, and we find figure out what the deposits are. So here they solve for PMT first, which I guess you could do that and plug it in. So they did it backwards in the way I did. They figured out the future value first, or the future present value, right? They figured this out first, plugged it in here, and then solved for that. But you can do it that way too. Mathematically, it's equivalent. Okay. And we get our payment, $4,000 something. So let's look at problem 2. Refer to example 2. So if we have $2,000 deposited annually, so PMT is $2,000 deposited annually, so M is 1 for 25 years. So I'll call it T1 is 25 years. How much can be withdrawn annually for the next 20 years? All right, So this is 55 years of stuff going on, right? So, where's our two formulas? I'll never remember this thing. So for the first 25 years, our future value, which I'll say, that's the future value for 25 years from now. That would be PMT 1 plus I. Let's see, what is the R here? Oh, they want us to use the same things from example 2. Okay, what is R? That's example 1. Here we go. R is 6.5%. So R is 0.065. So I would be 0.065 divided by 1. So it's 0.065. To the N is MT, N is 1, T is 25. We'll just write this as 1.065. That's easier. Minus 1 over I. So we're depositing $2,000 annually for 25 years and collecting 6.5% interest. At the end of 25 years, this is how much money we'll have, and we can actually plug this in. So if we type this in,
I feel like this one is really easier
it's not bad. There we go. Times, yeah, this one you don't have to graph. You can actually solve it mathematically. 1.065 to the 25th power minus 1, and then divide by 0.065 equals, so this is 117,775 and 36 cents. So that's how much you'd have in 25 years, right? How much can be withdrawn annually for the next 20 years? So now we need to use this formula. I'll never remember here. All right, we need to use this formula, replacing present, this future value is that present value, all right? So present value is our old future value. How much can be withdrawn annually? We're solving for PMT here, okay? So if we look at this formula, let's just do it this way. PMT, let me do this. PMT, if I call this future value, would be our old future value, and then divide by this guy. So this is the same thing as multiplying by its reciprocal, the same trick we did before. 1 minus 1 plus I to the negative N. All right, and we have all these numbers. We know what the future value is. We know what I is. I is what, 0.065. 1 minus 1.065. The negative N, we know what N is. Since it's 20 years, this is going to be to the negative 20 power. So just replace FV with this number and type that in. So we would have 111, no, that's too many ones. 117,775.36 times 0.065 divided by 1 minus 1.065 to the negative 20th power. I'll go back one. Gotta be a back button. Delete. There we go. Parentheses. Right. 117,775.36 times okay. 75.36 times 0.065 divided by 1 minus 1.065 to the negative 20 parentheses. Oh, yeah, I need one more. All right, that one's that one. There. Son of a bitch. All right. What am I missing? A parenthesis. 0.065 divided by 1 minus 1. Oh, no, that's to the power. I don't know, I cannot type it into this calculator for some reason. 0.065 divided by 1 minus 1.065 to the negative 20th power. Normal float auto real degree into. That's okay. This is okay. I do need a parenthesis there. There's 2 parentheses there, 2 parentheses here. I don't know, this calculator pisses me off. I'm typing it in perfectly correct, it just gives me an error.
Maybe that's why they left it here.
Right? 0.065, oh, there's my 117775.36 times 0.065 divided by 1 minus 1.065 to the negative 20th power. 1, 2, 4. It works fine in Mathematica here. You get $10,688.87. I don't know. This thing is quirky. I don't know what it wants. It's totally fine here. Maybe it wants.
It has its own idea of the definition of math.
Yeah, it's bullshit. Yeah, it wants an extra parenthesis around something that it shouldn't need. That is a number times a number divided by 1 minus a number in parentheses. Enter. I don't know. Piece of shit. I'm not going to use it anymore. All right, let's have a daily exam number 22. Let's do this match problem number 1. So number 1 was the example number 1 was easy, right? We just plugged it into the equation, right? For a new formula. That's going to be your number 1. Just do the match problem. And then number 2, we'll pick one of the simple wedge of into the section problems here. Amortization. I didn't get into math so I could do business. Like the last thing I was ever interested in. All right. This is like the least. Yeah, it's several companies. But I wasn't an accountant. Well, I did all the accounting because I had to, but I didn't create a company so I could do business math. You know? No, I wasn't a business major. I was a physics major, you know? I like creating cool stuff. I mean, all the money for the sake of money. The business people think that like the purpose of business is to make money, but it's not. That's a consequence of doing good business is to make money, right? purpose of a business is to create a good product or a good service at a good price for good people, you know? Alright, so yeah, we should be able to do this one. Oh, I guess we need instructions, you know? This is the stuff I wanted to do. These cool sums. All you need is the formula though. That's the fun part. Find I and N. That's easy. Yeah. Find I and N. I hope this is one of those stupid graphing problems. Monthly payments are made, we pay. I don't know. If this is one of those graphing ones, number two, if you have to graph to do it, don't do it. Alright.
Well, I guess we'll figure it out first before.
Yeah, I'm gonna do it pretty much right now. So, alright, that's it for class.